Hey guys, hi. This is Abhishek, Master Teacher of Physics at Vedantu, and good evening to one and on everyone who are present here. Welcome to the session. I should say master session. Correct. So today we are also going to do some amazing stuff as we have done in the previous webinar. So basically guys, I just want to thank each and every one of you who have supported the master sessions till now and who have got some knowledge or concepts from the previous webinars we have been gone through. Correct. So previous webinars we covered magnetic effects and all. So today in this particular master session, I believe let's take a common topic. Let's take a common concept where a lot of students face problem. Okay, shall we deal with that? Great, awesomely well done. And once again, hi to each and every one of you. I can see a lot of you guys here. Hi guys, hi, welcome to this session. Okay, so what are we going to do today? And before that, people who don't know me, let me give you guys my small and quick introduction. Today basically we are going to visualize physics numericals to solve faster without silly mistakes. Now this is one of the most common area where a lot of students actually fail in performing. I hope you understand my point, right? There are many students who learn very well. They are like school toppers, class toppers and everything, but the moment they go and write and sit in front of the question paper for the board examination, they go blank. Or whenever you guys are doing any numerical, you have a doubt in your mind whether I'm going to do it right or the answer which I'm getting is correct or not. So today guys, I'm going to teach you, we are going to learn together how to verify your answers and how to visualize the question which is given in front of you without even actually solving the numerical. Yes, you heard it exactly correct. Today we are going to solve the physics class 10th numericals without even actually solving it. You got my point? So all we are going to do that today. Okay? Now once again, to all of you, good evening and welcome to this session. For people who don't know me, my name is Abhishek. I'm a master teacher of physics at Vedantu. I personally handle 9th and 10th standard and more than 500 students are being mentored under me right now. 9th and 10th both. Okay? So basically guys, I'm also an aerospace engineer. So I have a course here at Vedantu called as Rocket Pro. I'm the inventor of that, as you can see here. So Rocket Pro is the only online practical learning course about rockets, and you heard it exactly correct, the practical learning course. Here we not only we don't only discuss the technical aspects, but we also learn how to build your own rockets, and the students build it by themselves. Many of you guys might have heard about it. Many of you guys might have joined the course also. So great guys, we'll be launching Rocket Pro in the month of October. So stay tuned for that. But today, let's focus our entire energy on something very important. That is what I discussed, how to visualize and verify each and every question for CBSE 10th physics. Okay, so let's start guys without spending any more time. But I want each and everyone to keep this in your mind, which is this thing. That is, the expert in anything was once a beginner. Once I was a beginner, now you are, and it's your time to become an expert. How do you become an expert? Just imagine about it. If you're able to solve the numerical without even solving it, then you are actually an expert doing it. Correct? So let's try to see how you become an expert. So today, since we have only 1 hour here, instead of taking the entire CBSE course or physics course of the CBSE's board, let's focus our energy on one particular topic which has a lot of weightage in CBSE 10th. That comes out to be CBSE board 10th concepts for concave and convex numericals. Okay, concave and convex mirrors. So today we'll be focusing completely on the mirror concepts. I have a course which we'll be discussing later about it, where we'll be covering lens and all the concepts of electricity. I'll discuss about that later. But right now, let's focus our energy on the concepts of concave and convex mirror numericals. And let's try to understand how to solve these numericals without actually solving them. Let me give you the best tips and tricks and the best approach to get into them. Cool. Let's then start solving it, guys. Okay. To jump into the numericals, you basically require few important concepts already in your mind. And since you guys have already given your midterm examinations, and I think majority of the schools have covered the chapter light reflection refraction, I'm going to assume you are well aware about these three concepts in front of you. That is number one, ray diagrams. Number two, sign convention. Number three, the formulas related to the mirrors. Correct? I'm going to believe that you guys know, but once again, let's do a quick revision of all of them. Okay, let's do that so that it's fresh in your mind and it's on your fingertips for this entire session. Okay, so everyone concentrate here very carefully. Let's go and do a quick revision of the ray diagrams for concave and convex mirrors. But we'll not be doing the same old ray diagrams and all. We will go and do a simulation. Okay, here is a simulation here which you can see in front of you. With the help of this simulation, we'll try to understand what are the various ray diagrams. Cool guys? Now basically, if I talk about it in general, there are in total 16 ray diagrams in your syllabus. 16 ray diagrams. Out of these 16, 8 ray diagrams are for mirrors and 8 ray diagrams are for lenses. Correct? Out of these 8 ray diagrams, 6 ray diagrams are for concave mirrors and 2 ray diagrams are for convex mirrors. This is what we are going to understand right now. Okay, 6 ray diagrams for concave and 2 ray diagrams for convex mirrors. Okay, so guys, quickly answer the questions which I'm going to ask you guys right now. I believe all of you guys know this concept. Yeah, so let's try to understand. So the first ray diagrams which come for a concave mirror, I believe all of you guys understood that this is a concave mirror right here. Yeah, give me a quick yes. Who all identified that's a concave mirror? You guys are doing super great. If you have identified that, superbly great job. Yes, I could see many of you guys identified it. Great job guys. So it's a concave mirror right here. I have a focus in front of it and I have the 2F. 2F is nothing but the center of curvature. As you guys know, focus, radius of curvature is the double of the focus. So this is your radius of curvature which ends here and that becomes your center of curvature point on the principal axis. I believe all of you guys know about it. Now moving forward to the ray diagrams. The first ray diagram, as you guys all know, focuses on the concept that when the object is at infinity, this candle which you see here, this is your object. And this object is now at infinity. I cannot go till infinity, so I'm keeping it as far as I can. Okay. So when the object is at infinity, you can clearly see where is the image formed, guys? Ping me on the chat right now. Where is the image formed when the object is at infinity? I'll give you 10 seconds to answer this. Just 10 seconds. And now you have 5 seconds. Great. Very good. Exactly correct. So very good guys. I'm so proud of all of you guys are doing really great. So when the object is at infinity, as you can see, the image formed is at the focus. If you can't see the image, I'll bring the object closer. Can you see the image now? Yeah. So that image is formed at the focus and it's pretty visible to you that the image formed is inverted. It's inverted and also the image formed is real. Correct? In the case of a concave mirror, out of the 6 ray diagrams, in 5 of the ray diagrams, in 5 of the positions of the object, concave mirror forms a real image. And in one of them, it forms a virtual image. We'll discuss that one by one. So as the first ray diagram goes, when the object is at infinity, the image is formed at the focus. It is a real image, inverted image. Got my point? And the size of the image, as you can see, it's too small, very, very small. Very small. Correct? So let's just find it out. Look at this. Object height is 14.8 centimeter, that is closer to 15 centimeter, but the image height is 2 centimeter, very small, 2 centimeter as compared to the object. So that checks out our first table here, that when the object is at infinity, the image is at focus, highly diminished, real and inverted. Okay? Now similarly, let's move forward for the second scenario, where the object is kept beyond center of curvature. Beyond center means behind center of curvature. This is my center of curvature right here, and you can see I've kept the object beyond center of curvature, and in that scenario you can notice the image formed is still real and inverted, but it is formed in between focus and center of curvature. Correct? As you can see, from infinity I have got my object beyond center of curvature. and the image is formed between center of curvature and focus. As simple as that. So this also checks out the second point, that when the object is beyond center of curvature, the image formed is between F and C. The image is still diminished. If you notice, the image is still diminished. It's not enlarged more than the size of the object. No. As you can notice here also, 15 centimeter the object size, but the image size is closer to 6 centimeter, not as big as that. Cool. Great job, guys. So that also checked out. First ray diagram done, second ray diagram done. For the numericals, you don't have to, remember the intersection and all those stuff. You just need to remember, if the object is here, where is the image? That's all you need to remember. So infinity, focus, beyond center of curvature, in between focus and center of curvature. Okay? Now, let's move on to the third scenario, the special scenario, one of the most easiest one, that is whenever the object is on the center of curvature. Look at it very carefully. The object is on the center of curvature. Exactly. You can see that? The image formed is also on the center of curvature. It's real, inverted. And if you notice the size here, the sizes are also same. Correct? So that's why it's a special case. Everything same. This can only happen when the object is kept at center of curvature. So I'll repeat again, when the object is kept at center of curvature, image is also formed at center of curvature, and now the size of the object and the size of the image is same, and you get a real and inverted image. That is the third ray diagram for concave mirrors. Now once you have done that, we'll proceed forward and we'll jump on to the concept when the object is now kept in between center of curvature and focus. What do you see now? You see that now the image has become greater than the size of the object. And also one more thing to notice very clearly, guys, doesn't it look the opposite of one of the other ray diagrams which we already studied? Doesn't look the opposite of one of the other ray diagrams? Which one is that? Can you tell me now? Which one is that? Just think and tell me which other ray diagram resembles it but in the opposite manner. Very good. Think about it, guys. I'll give you 5 seconds to think about it. Come on, go for it. You have 5, 4, 3, 2 and 1. Time's up. I could see many of you guys give me the correct answer. Well done, guys. Awesomely well done. The ray diagram which it is resembling the opposite manner is when the object was kept beyond center of curvature. The object was beyond center of curvature. The image was between C and F and it was diminished. Now I bring the object between C and F. Image is bigger than the object, opposite, and the image is beyond C. So it's entirely opposite. Correct? Every position, every size is now opposite. Great job, guys. So that's very quick to remember, and you can see very clearly this is the first time we have got a magnified image from a concave mirror. And please note that point right now. Out of the 6 ray diagrams, in 3 ray diagrams which you studied before this, the image size was diminished and equal. 2 ray diagrams completely diminished and 1 ray diagram equal to the object. Now we are gonna go for magnification. So now we have the image greater than the object size. That happens in the 4th ray diagram when the object is between C and F. Bas, keep these patterns in your mind. You are going to rock completely. Okay? Now move. So now let me just check this part also. Object between C and F, image beyond C. The size of the image is enlarged and it's again real and inverted image. Superb, guys, superb. Moving on to the 5th ray diagram when the object is at focus. Now when the object is at focus, you can see very clearly that you cannot see the image at all in front of you. It has gone somewhere. It has gone completely somewhere, and that somewhere is nowhere else but the infinity. Isn't it so? It's at infinity. And now who can tell me which ray diagram is this ray diagram opposite to? Which ray diagram is this ray diagram opposite to? I'll give you 5 seconds again to answer this. Come on guys, quickly give your full here and let me know. Focus your energy completely here. Your time ends in 5, 4, 3, 2 and 1. That's super great. I could see many of you guys giving the correct answer. Very nicely done. The image formed is at infinity, and this is exactly the opposite of the first ray diagram, and the object was at infinity and the image was at focus. So now the object is at focus, image is at infinity, and it is super magnified, super magnified. Before it was highly diminished, now it's super magnified. That checks out my fifth ray diagram. When the object is at focus, image is at infinity, highly enlarged and real and inverted image. But now comes something we call as Mr. Special. Something we all call as Mr. Special. Why is this special? Because this is the only ray diagram of concave mirror where we get a virtual image. This is the only ray diagram in the concave mirror where we get a virtual image. That's why we call it as Mr. Special. Now let's just check it out. How is it going to be formed? For this to be formed, your object distance must be less than the focal length. Look at that. The moment I came in front of the focus, as you can see, the image shifted from left to right. Can you see that? From left to right. It just shifted the moment I came in front of the focus. So for a virtual image to be formed, please note it and write now that the object distance must be less than the focal length. And yes, now you can see the image is formed on the right, a virtual image. And since all the images are erect, which are virtual, you get a virtual and erect image. The only scenario for a concave mirror. The only and only scenario for a concave mirror. Got it, guys? So that was the 6 ray diagrams for a concave mirror in front of you without any problems. Got a point? So that was it, 6 ray diagrams. So I'm gonna check out the final one. I hope all of you guys were able to revise that as well. Enlarge, virtual and erect, done, all set, no confusions at all. This also done, this also done, this also done. Give me a quick thumbs up if you have understood all that well. Yes, awesomely well done. That brings me to the only left 2 ray diagrams. Just left 2 ray diagrams for convex mirror. The convex mirror is like us, you know, it's very cute. I would say cute because basically it has not much to understand. There are only 2 ray diagrams, as you know, out of 8 ray diagrams, 6 ray diagrams for concave and 2 ray diagrams for convex mirror. So it's very cute, basically very cute. So how do you draw that? There are only 2 cases. I'll show that to you. So this has now become a convex mirror because I have taken my object onto the right hand side. Okay, because convex this is now, so okay, object here. Okay, basically. So now if you notice, when the object is at infinity, number 1 case, number 1 ray diagram, you cannot see the convex mirror at all. You cannot see the image at all because the image is at focus. Can you see the image now? Very clearly see the image is coming out from the focus. So basically the first ray diagram states whenever the object is at infinity for a convex mirror, the image is at the focus. Completely true. Then what is the difference between concave and convex? The difference is, which you need to note it down right now, convex mirror is forming a virtual and erect image there. And convex mirror always forms a virtual and erect image. It is, as I said, it's very cute. It is very simple, not much complications like concave mirror. Concave mirror can form 2 kinds of images, real also, virtual also. But the best part about this is the virtual image formed by a concave mirror is only once. And how is that happening? When the object is between focus and center, between the focus and the pole. That's the only scenario, and you can notice that the image formed by the concave mirror is magnified. The virtual image of concave mirror is magnified, and guys, this is also one of the CBSE 10th questions. Okay, very important. Note it down. And now when I shift my convex mirror here, you can see very clearly that the image formed by convex mirror is also virtual and erect, but it is not magnified. It is small, very small. It's diminished. You can see here 15 centimeter object, image is 7 centimeter only. Got a point? This is also a very important CBSE 10 question which I already stated you. that what is the difference between virtual image created by a concave mirror and a convex mirror. Simple. The difference is size, where concave mirror forms a magnified image, convex mirror forms a diminished virtual image. Okay? Now, as I stated, there are two ray diagrams for convex mirror. One of the ray diagrams you just saw right now, where the object is at infinity and image is at focus. So let me just cross that also down. So object at infinity, image is at focus, highly diminished image and a virtual and erect image. Moving to the second and final ray diagram for today, that is when the object is kept anywhere in between infinity and the pole. Anywhere in between infinity and the pole, you would see that the image position is not varying much. It is still in front of the focus and between the pole only. Still same to same. There is no difference at all. That's the entire point about it. It's not complicated at all. That's why it is very, very simple. That's only two ray diagrams. Kahin bhi rakh lo. You can keep it anywhere. It's in between focus and pole only. Kuch bhi kar lo. Got a point? So that's the entire scenario, and that checks out our position of object anywhere on principal axis, position of image between pole and focus only. It's still diminished and virtual and erect. So guys, out of the prerequisite concepts which you required, we have completed the ray diagrams for all sure. Now I believe all of you guys know the sign convention. We'll take a quick revision for that, and we'll jump onto the formula, and then we'll go for the numericals. Okay? So for 5 to 7 minutes we'll do this, and then it's all and all numericals. So stay with me, completely focus here, because for numericals and to verify your answers, visualize your questions without solving it, you need to know these three concepts. That's why we are spending so much amount of time for revising this. Okay? So guys, now moving for the sign convention, all of you focus here completely. Okay? So sign convention, one of the simplest things. I believe people who don't know about it, the best way to revise sign convention is to do a Cartesian system. Okay? To make a graph. You make a graph, you understand sign convention completely. Let me show you how, if you don't know about it. Okay? So let me take this as my vertical axis, and then I'll make my horizontal axis, that is your x-axis. I want all of you guys to answer each and every question I ask this part. Now guys, at this particular scenario, I will first make my concave mirrors ray diagram. This is my concave mirror right here, and I am making sure that the concave mirror I have made has the pole exactly at the origin. Okay, the pole is exactly coinciding with the origin of the y-axis and x-axis intersection. So I'll call this as my y-axis, this as my x-axis, this as y, and this as x again. Now I believe all of you guys know that y-axis is positive on the top, y-axis is negative on the bottom, correct? X-axis is positive on the RHS, I'll name this as RHS, and x-axis is negative onto the LHS. You guys are pretty clear about that also, correct? Now guys, in the entire scenario we were visualizing visualizing the concave mirror here. Was there any movement the object was kept behind the mirror for a concave mirror? Was there any movement where the object was behind the mirror? No. And you cannot keep the object behind the mirror. Kya dikhega? You will see nothing, because behind the mirror it is non-reflecting surface. So what will you see? You will see nothing. So basically you need to understand here that the object is always kept in front of the mirror. Correct? Always. So with that particular part, if we go back and solve it here, I can say that the object is kept at the left hand side, and you know that it's going to be u. U is the object distance. I believe all of you guys know. U is called as the object distance, OD, object distance, which is equal to here a negative value or a positive value. What would be our answer? Just think about it and tell me. As all of you guys know, it's forming on the left hand side. Completely correct. Left hand side, x is negative. So object distance is going to be negative. Exactly correct. Exactly correct, guys. Very good. So I'm going to write it down right now that u is going to be negative always, and I'm going to write down u is always going to be negative, and your v for concave mirror For all the cases except the virtual image case, for all the other cases you can see that the image is being formed on the left hand side only. So that would mean here for all the real and inverted cases, for all the real and inverted cases, your image distance for concave mirror is negative for all the real cases, because image is being formed on the left hand side. Simple. Left hand side x-axis is negative, you know that, correct? That's what we written. Similarly, so V is image distance. If you don't know about that, you must know that. So V is image distance. Similarly, guys, when we talk about the focal length of a concave mirror, as you saw very clearly, the focal length for a concave mirror is also on the left hand side. Why is it on the left hand side and all? We will discuss later. That's not the part of it. Let's focus here. So focal length is also negative. And as you guys know very clearly, before writing down focal length, I think I should make it clear that V is going to be positive for virtual images. Correct. Because it's forming on the RHS. Cool. Awesomely well done. So V negative, V positive, काम खत्म. अब आगे बढ़ते हैं F में, and F is negative, which you understood right now. Now moving on for the height of the object. Look at this very carefully. All the height of the object is positive. And how do we know that? Because it's kept above the y-axis like this. So what is the height? Somewhere about 2, sir. What is the height? Somewhere about 4, sir. And all the y-axis positive, all the y-axis on top is positive. So H is always positive. Very good, guys. I can see a lot of answers in the chat. You guys are doing amazingly well. You guys are killing it. Very good. So H is always positive, no doubts about it. And finally H dash, that is the height of the image, is going to be what? For again all the real cases, as you guys know, the image is inverted. All the real cases image is inverted. So my image will be forming like this, inverted. What is the height? Sir, -2. Now what is the height? Sir, -4. Correct. You will say like that as a graph. Exactly correct. So for all the real cases, your H dash is negative. Simultaneously, H dash is equal to positive for all the virtual cases. For people who didn't know this, I have given you the entire concept. Look at this. How for virtual it is positive? Look at this. Virtual image forming on the right hand side on top of the principal axis. Now both object and image are on the top. So hence, what a positive value. Just like that, it will be here. So sir, what is the height? Sir, it is 3. Positive 3. That's it, guys, for the ray diagram and the sign convention for concave mirrors. We have done it entirely well, revised it completely. Now jumping on for the convex mirror cases. Okay? So this I will not do. This I want you guys to do it right now. I will give you 20 seconds. By the time I make the axis and by the time I make the convex mirror, I want all of you guys to decide and tell me what is U, V, F, H and H dash for convex. I want the answers on the chat in the next 20 seconds. Your time starts now, guys. Let me know what is the answer. Okay? So by the time I'm making it, guys, I made my y-axis. Okay, guys, I made my x-axis. Guys, now I'm naming them. Positive, y negative, down. Guys, I am naming the RHS also. Positive, x. Guys, I have named my LHS also. X negative this side. Guys, I am going to make the convex mirror now. Please be very, very careful. This is my convex mirror converging with the origin. Guys, I am done with the pole and the origin. Okay, your time is up, guys. Your time is completely up. Now focus and tell me what is it. ठीक है, अब बताओ मेरा क्या आंसर है. I will ask you about U. So what is U, guys? For a convex mirror, what is U? Exactly correct. Very good. Awesomely well done. Look at it, guys. No matter U or V, no matter concave mirror or convex mirror, nothing can be kept behind the mirror. This is your convex mirror. This is the reflecting surface. Everything must be kept in front of the convex mirror. So your object is kept in front of the mirror. Hence, it is still negative. Very nice. What about V? You know that your convex mirror always forms a virtual image. So that is always on the RHS. Hence, your V for a convex mirror is always positive. Note it down. Right now, note it down. That's the point right there. Note it down. V is always positive for your what? Convex mirror. Now let's move on to focal length. You know very clearly the image for a convex mirror is found between the focus and the pole always. Hence, the focus for a convex mirror is on the RHS. Hence, it is positive again always. Now again, to go deep in it, why is it positive? Why is it not negative, sir? Later, not today. Just remember, focus is always positive for convex mirror. Moving on to H. Object height, sir, again sir, always positive. No doubts about it. Okay? No doubts about it. It's also always positive. Let's talk about H dash, that is the height of the object. You know that your convex mirror always forms a virtual and erect image. Hence, it's going to be always above the x-axis. So always you are going to get this image itself, sir, height 2. So H dash is also always going to be positive, guys. Look at that. As I told you before, convex mirror बहुत simple सा, sweet सा, cute सा thing है. So basically everything is always, there is no changing there. Not complicated as concave mirror. Got it? That is the sign convention right there for both the mirrors. All the ray diagrams done. Moving on to the final part and one of the most important parts, guys. Okay, so sign convention also done, guys. No doubts about it. अब आगे बढ़ते हैं for the final thing, the formulas. Maybe the smallest part of this particular part, because all of you guys know what is the mirror formula, right? So guys, I've written here very clearly कि sign convention कैसा होता है. So when you download the notes, you can go for it. So don't worry about it. But right now, let's focus on the formula. The formula for mirror, called as mirror formula. Please note it down very clearly. Mirror formula क्या होता है? I believe all of you guys know what is mirror formula. Mirror formula is said to be nothing but 1 by f is equal to 1 by v plus 1 by u. That is mirror formula, where f is the focal length, v is the image distance, u is the object distance. Cool? Awesome job. Now let me take the part of magnification. ठीक है? Magnification formula for mirror scenario is minus v by u, where v again is image distance, u again is object distance. Now here lies the most important part. Magnification is also known as h dash by h. This magnification right here, guys, is very, very important because it tells you one very important thing. And please make a note right now, guys. When magnification comes out to be negative, you know that it must be a real image. Magnification, when it comes out to be negative, it must be a real image. Now you must be thinking, sir, how is this possible? How can you say that? Let me prove it to you. The formula for magnification, as you guys know, I'll write it down here. M is equal, you can take any formula. Let me take h dash by h. If I take h dash by h, think about it. Let's take the scenario of a concave mirror, because concave mirror forms a real image. So take any scenario. Let's imagine, scenario where a real image is formed in the case of, the second scenario, when the object is beyond center of curvature. Let me take that. When the object is beyond center of curvature, you can see h dash is, h is positive, h dash is negative, correct? So if I write that down, I will get, what to say. H dash is a negative value, real scenario. H is positive value. Negative and positive must give you negative itself. So as I said, it's forming a real image and you got a negative value. How you prove it? If you want to prove through minus v by u, you can do that also. Look at this. M is equal to minus v by u. I take v, when it is real and inverted, it's on the left hand side. You already wrote down the sign convention for concave mirror. When v is on the left hand side, it is negative. So I'll write that down now. Okay. So I'll write down v as negative. So yeah, negative and sign there. U is also negative always. So negative. This negative cancels out and you get a negative value again. So this is how you prove it. So magnification is negative for a real image. Similarly, magnification is positive for a virtual image. Got it, guys? Very simple. This also you can prove it out very clearly, correct? If I take the second part, you can try out the first part whenever you're free. Second part, if I take m is equal to minus v by u. V for a virtual scenario. Let's take the case of a convex mirror case. For the convex mirror case, oh my god, okay, for the convex mirror case, when the object is in front, for the concave mirror case, let's take it out. When the object is in front of focus and pole, if I write down negative value for u and your image is formed on the RHS, so I'll write down positive for that. So when this and this gets cancelled, you are left with a positive value, and that's what I'm trying to prove here, that positive means virtual image. Magnification positive, it's a virtual image. Bas, itna hi. I hope it made complete sense to all of you. Now, one more thing which you need to note it down right now. That is, what happens if magnification is greater than 1? And guys, this is a very common mistake which a lot of students do basically. Whenever I say magnification is minus 2, for example, if I tell you magnification is minus 2, now everyone please put down in the chat, is this a magnified image or it's a diminished image? Just think and tell me, is this a magnified, when m is equal to minus 2, is that a magnified image guys or it's a diminished image? What do you guys think? Okay, come on guys, put it down. I'll give you 5 more seconds. Okay, the time ends in 3, 2, 1, time's up. I could see plenty of magnified and I also see few of being saying diminished. Correct. Guys, please try to understand this. This negative sign for a magnification only and only tells you whether the image is real or inverted. Sorry, real or virtual. It doesn't tell you whether it is magnified or diminished. That is being said by this other number which is given in front of the sign, 2. And that value, that 2 is greater than 1. Hence, it's a magnified image. Whenever it is greater than 1, it's a magnified image. You want proof for that? I will prove it to you, not a problem. Imagine magnification is equal to h dash by h. When m is greater than 1, that means h dash by h is greater than 1. That means h dash is greater than h. Isn't it? M is equal to h dash by h. If m is greater than 1, that would mean h dash by h is greater than 1. That means that h dash is greater than h. And what is h dash? H dash is nothing but image height. H is nothing but object height. That means your image height is greater than the object height, isn't it? We did it, guys. We completed it. Great job. You were rocking. Very good. Similarly, if I tell you, if m is less than 1, it is diminished. You can do the same proof here. Go for it. H dash by h will be less than 1. Hence, you will get h dash is less than h. Image height is less than the object height. It's a diminished image. So never again take this negative sign seriously. Never do that. Cool, guys. Awesome. Great job. So with that, guys, we have done all the prerequisite concepts completely. So within the next 20 minutes, you are going to understand how to solve all the kinds of numericals related to reflection without actually solving it, starting from right now. I will give you this question and I'll give you exactly 2 minutes to solve this question. Let me see how many of you guys answer it exactly very correctly. Then I will show you how to do it without actually solving it. Is there anyone who can tell me without actually solving it? You can go for it also. Simple question, guys. It states an object of size 7 centimeter is placed at 27 centimeter in front of a concave mirror of focal length 18 centimeter. At what distance from the mirror should a screen be placed so that a sharp focused image can be obtained? So ultimately in this particular part, they are asking you to find what is the image distance. Then they are asking find the size. Size means h dash, and the nature of the image. Nature means real or inverted. So ultimately you need to find here magnification. So find out image distance, magnification, then go on for h dash. Go for it, guys. You have, I think, 1.5 minutes left. Go for it. I could already see many of you guys are able to ping me the answer on chat with just looking to it. Very great, guys. You guys are rocking today. You guys are killing it. Go for it, guys. Come on. We need to finish this within the next 15 minutes and you will be able to do it, guys. I'm super proud of you on this. Come on, guys. Quickly do it. Okay. You have exactly 1 minute more. Come on. Come on. I'm waiting for all of you. 1 minute more. Exactly. I'll give it to you. And I completely believe that you guys all know the answer to this question. 1 more minute is what I'm going to give you. And now you have 50 seconds more. Just 50 more seconds, guys. First, find out image distance. Take the sign convention very properly. If you do a mistake in sign convention, then to gone case. Fir to live jingle ala. I'm telling you that. You will not get any answers. Okay. Great. I could see many of you guys pinging me, option A here. Many of you guys pinging me option B also, C also, D also. Great job, guys. Keep on doing it. And now you have exactly 20 seconds left, not more than that. Within 20 seconds, we'll end the thing, guys, and I'll discuss the answer with all of you. And I will show you how to do it without even actually solving it. I'll give you the answer. Very clearly, I'll give you the answer. Okay, and your time ends in 5, 4, 3, 2, and 1. So that's it, guys. Time is up. Now everyone concentrate and understand how to do this and become an expert. Okay. First of all, guys, let me tell you that this question can come for 3 marks also and 5 marks also. 3 to 5 marks, this question can vary. But for both the scenarios, you need to make a ray diagram. Okay. And that is the best part, because with the help of ray diagram, I will know what is the answer. Let me show it to you. Let me show it to you guys how to do this amazingly well. Okay. Let me create a new page. Now, guys, just help me out doing this. An object of size 7 centimeter is placed at 27 centimeter in front of a concave mirror. I don't care about any of the statements which stated anything. What we care about is that this is a concave mirror. So my first step, I will make a concave mirror. Made. Principal axis, bana diya. Pole, ban gaya. Focus, done. Center of curvature, awesomely well done. Next important thing. What is the object distance? Is placed at 27 centimeter. Awesome. And what is the focal length? Focal length is 18 centimeter. Balle balle. So I can see that focal length is kept at 18 centimeter. Now before putting the object, I would like to ask each and every one of you, if focus is 18 centimeter, what is the center of curvature? Where must be center of curvature? Where? Exactly correct. You know it must be the double. So 18 ka double, 36. So that means center of curvature is between, here 36 centimeter. Exactly. So that means object which is at 27 centimeter is in between focus and center of curvature. Isn't that mean? Correct. 27 centimeter object distance. मान लिया u is equal to negative 27 centimeter. Left hand side. What do you guys think about this? Now look at this, man. Look at this very clearly. The object is between C and F. So guys, for a concave mirror, where the hell must be the image formed? Where it must be formed? As you guys know very clearly, according to ray diagrams, that is why ray diagrams are important. As you guys must have understood very clearly now, when the object is between C and F, the image must be formed beyond C. The fourth ray diagram right there, it must be formed beyond C. That means the image distance which I will get must be a negative value because it's on the LHS, and that value must be greater than 36 centimeter. Must be greater than, because center of curvature is 36 centimeter. It must be beyond that. So it must be greater than 36 centimeter. And now I know that the magnification M, since it's a real image being formed here, obviously object is between C and F, there is no way it can form a virtual image. So magnification must be a negative value. Done. Okay, and look at that. It's an inverted image. So your h dash value must also be negative. It's an inverted image, isn't it? Now let me show you guys the option. I have here two options, that is option A and B, giving me a positive h, hence out of the picture. Moving to the third and fourth option, and now it's pretty clear which is the correct answer. One of them is 14 centimeter, one of them is 7 centimeter. Which of them is correct, guys? Let me tell you this. The object distance is the object height is 7 centimeter and image height also 7 centimeter. Can only happen, correct? Object height and image height can only be equal when the object is exactly on the center of curvature. But that's not the case here. Here the object is between C and F, and in that case, in the fourth ray diagram, I get a magnified image, correct? So that would mean my m value will be greater than 1 also, and h dash value must be greater than the height of the object. Hence 7 centimeter is the 14 centimeter is the correct answer right here. So guys, without even touching a single word from the numerical, without even doing one calculation, we were able to find out which is the correct answer within 2 minutes. And the more practice you do, the better you're going to get at it. Because once you know this, see, now you know everything. Now you know everything. Ki mera v must be negative, v must be above 36, my m must be negative, m must be greater than 1, my h dash is must be negative and must also be greater than 7 centimeter because that's the object height. So this is how this. So there is no way you can go wrong in here. There is no way, because now after this everything is calculation. So with the help of this, guys, you will be able to verify your answer, do the numerical without even one single silly mistake. No way at all. Let me show it to you. Let me show you how fast you can do now the mathematical calculation with so much of confidence. V, you need to find it out, correct? Focal length given to you minus 18 centimeter. Now you can just go forward, guys. Go with the formula. 1 by f is equal to 1 by v plus 1 by u. When you go for it, 1 by v is equal to 1 by f minus 1 by u. Shifting it, you will get 1 by v is equal to 1 by minus 18 centimeter minus of u. U is again 27, so this will become plus because negative negative positive. I will get 1 by v is equal to 27 minus 18 is 9 divided by minus 18 into 27. 9 ones are 9 twos are. I can see very clearly I am going to get a negative value. 1 by v is equal to 1 by minus 54. Hence v is equal to minus 54 centimeter. And look at that. You wanted a negative value. You got it. You wanted a value greater than 36 centimeter. You got it. That's how you verify your answer. Got it. Now let's move on to find out magnification. M is equal to minus v by u. You want a greater than 1 value, negative value. Minus, you have got minus 54. Write it down, minus 54. U is nothing but negative here. What is the value of u? U is minus 27. Awesomely correct. Negative, negative cancel. You have 27. 2s are 54. Minus 2. And I have no doubts in my mind that's a wrong answer because that's a negative value. I wanted negative value. That's a greater than 1 answer. I wanted that and we have got it. Finally, moving on to h dash by h. M is equal to h dash by h right there, guys. And h dash I want, which is m into h. I want it to be negative and greater than 7. M is minus 2 into h is 7. I have got minus 14 centimeter without any doubts, and that is also correct. Look at this. We were able to do the calculation in 1 minute. Verification took 1 minute. Within 2 minutes, you have got 3 to 5 marks confidently. You are now not in doubt now. You will not go back home with the doubt in your mind that you might have given a wrong answer. No, guys. Let's take away that scenario from your minds completely. Great. I hope now all of you must be feeling a bit confident. Let's boost up that confidence by doing one more similar kind of a numerical. X dash is equal to minus 14. You can see that. Let's do one more numerical, a very similar one. Go for it and let me know what is the answer. Now you no need to find the size. You just need to find out the magnification. Now try applying this verification method. Just try applying this verification method, guys, and you will be rocking completely. Trust me on that. Just apply the verification method. Go for it. An object is placed 15 centimeter from a concave mirror of radius of curvature 60 centimeter. find the position of the image and its magnification. We just need to find out V and you need to find out M. Try applying the verification process and give me the answer in just 1 minute. It cannot be harder than this. It cannot be easier than this. So harder it seems. It cannot be easier than this, guys. Come on, just think about it. In CBSE 10 board examination, you are sitting and you already know what should be the answer you must get. And trust me, that would be the best feeling you will ever get. Trust me on that. Great job, guys. Awesome. Okay, I could see many pings already here. Interesting work, guys. Very interesting work. Great job. Don't guess. Don't guess. Think about it. Do not guess at all. I could see many of you guys giving me the correct answer here. Very nice. Try applying the verification. Are you guys applying the verification? Yes or no? Applying the verification method or not? Please do apply on that. Okay, please go for it. Okay, great. Awesome. Awesomely well done. Chalo. You have exactly 10 more seconds, guys. And your time ends in 5, 4, 3, 2, and 1. And your time is done completely. So let us discuss what could be the answer to this question. Okay? Let's find out what is the answer. I want everyone to concentrate here. Focus your energy here. Let's try to understand. An object is placed 15 centimeter from a concave mirror of radius of curvature 60 centimeter. Okay? Let's make a ray diagram. Okay? An object is placed 15 centimeter from a concave mirror. Okay. So radius of curvature is 60 centimeter. And again, the important part here is concave mirror. So let me make a concave mirror. Made a concave mirror. This is my principal axis, all set. My pole, my focus, my center of curvature without any doubts. Center of curvature is at 60 centimeter. Awesome. So that means radius of curvature ka adha, that is half, is focus. So your focus is at 30 centimeter. Awesome. Now so I'll write down F is equal to minus 30 centimeter, all set. Now, an object is placed 15 centimeter from a concave mirror. Guess the part. What did they do here? They have kept the object 15 centimeter away from the mirror. That means the object is here somewhere. 15 centimeter. So your object is in front of the pole and between F and P. And as you guys know, this is your 6th ray diagram when you get a magnified, virtual and erect image for your concave mirror. Correct. So my image will be, and you also know that is going to be in between focus and pole on the other side. So here is your image somewhere. So now you know it must be magnified image. So M must be a positive value first of all, and M must be greater than 1. Let's check it out. Negative out of the picture. Positive greater than 1. Good content then. Option C, M is equal to minus T, out of the picture again. So magnification plus 2. Great. So we have very good conductors here. Plus 3 and plus 2. Can anyone be the answer? Correct. So now you have reduced down your option size into plus 3 or plus 2. Let's try to find out what is the answer. You just need to go and do what? Find out the image distance and let to know the answer. The image distance will be what? 1 by V is equal to 1 by F minus 1 by U. So 1 by V will be equal to 1 by minus 30 minus 1 by U becomes positive 1 by 15. You are going to get an answer as and you must get image distance as positive here, as you guys know, because it's on the RHS, correct? So image distance must be positive. Keep that in mind. And image distance, I think, must be less than the focal length also, because it's in front of the focus on the right hand side, correct? So it will give you minus 15 divided by minus 30 into 15. So 15 cancel and you get positive value here, that is V is equal to 30 centimeter. So it's exactly on the focus. That's completely fine, not a problem at all. It's a positive answer and we have got it. Let's check out magnification. M is equal to minus V by U. You again must get a magnification of positive value and greater than 1 value. So minus 30, U is negative 15 and you got positive answer, which is nothing but 2. Hence magnification is plus 2. And guys, please also keep this in your mind. in most of the cases, for this scenario, when the object is kept between focus and pole, you will get m is equal to +2 only. And this, I'm giving this you guys this as a tip here. Expect an answer is equal to +2. This will also give you a hint for this question as well, which we just discussed before this. In this scenario also, when the object was kept between C and F, in most of the cases we will get a magnification of -2 itself, as you saw here. Most of the cases, whenever the object is between C and F, you get a -2 answer. Whenever the object is in front of focus, you again there also get a +2 answer. This is what have been expected. Okay, so if you're getting an answer, apart from that, have a quick check key you are doing right or not, and also you have the verification process with you. Correct? Awesomely well done, guys. Awesomely well done. So I believe all of you guys are clear with the concave mirror part. Before moving on to the convex mirror part, I would like to tell you guys one very surprising thing. That is nothing but, guys, we are launching a course only for 2 hours where you'll be learning same kind of concepts, how to verify your answers, how to visualize your answers, and how to write down the answers in the CBSE 10th board examination without any silly mistake and by knowing what is the answer. Okay, and this course is only for 2 hours, going to happen on 2nd October 2018, only for 2 hours from 6:30 p.m. to 8:30 p.m. The price for this particular course, as a surprise, it's just ₹51. So you can join it anytime you want. But I should mention here, it's a limited seat course. Please make sure of that. It's a limited seat course. And to join for this particular course, you need to go on to this particular link here, where you'll be learning a lot of stuff regarding the CBSE 10th. I'll be completely focusing on the convex mirrors and lenses, concave mirrors and lenses, and also very critical problems from electricity as well. So once you go on to this link, please note that down right now. It's vdnt.in/numphy10. Now numerical physics 10. That's what it means. Once you go on to that link, you will find out that this is it. This is the link. Once you go into it, you will find out that what are we going to cover up? We are going to visualize and verify every question from light and electricity. Visualize, because physics is all about visualization, and verify your answers as well. In-depth concepts with numericals on mirrors and lenses. I will tell you the way to solve lens problems with the same kind of an approach by verifying your answers and visualizing your answers. And then we will definitely solve some crazy numericals on resistors, and also we will get tips and tricks to solve Ohm's law, power circuits, and heating effects of current. All that we'll be doing in this particular course. And guys, even after the course is ended, for 2 hours after that is ended, we are going to be in complete touch with the WhatsApp group for real time, completely for doubt solving. And you will get live and interactive online course for obviously, and the session will be recorded so that you guys can watch it again you want, how many times you want. It's completely on you. Okay guys, so completely, you have nothing to lose here. Great job guys, awesomely well done. So with one more numerical today, we'll end the session. Because we have not done yet convex mirror problems, let me give you guys a convex mirror problem. Okay, so yes, m is equal to +2 here, as you guys have understood already. Go for it guys. It's a very simple convex mirror problem. Let me know what is the answer. Since it's a convex mirror problem and you know the sign convention, I will give you 2 minutes for this as well. And also I'll give you guys a homework for today. Okay, and the homework you guys can put down in the comments below what is the answer to it. Let me see who answers it first. Cool? Okay, great. So go for it this question guys, and let me know what is the options, and with that we'll end the session for today. Go for it, give your complete energy here and finish this off. Come on guys. M is equal to -0.33, M is equal to 0.666, M is equal to -0.922, M is equal to 0.223. What do you think is the correct answer to this question? You have exactly 1.5 minutes left. A convex mirror is used as a rear view mirror for a bus, has a focal length of 200 centimeter. If a scooter is placed at 100 centimeter from the mirror, find the position, nature and magnification of the image You don't even have to find out the size again. You just need to find out the magnification, guys, and you guys can rock it here. Come on. I could see many answers on the chat. I'm super proud of all of you guys. Super proud of all of you guys. You're doing completely great. Come on, guys. Just kill it. Come on, just kill it. You have exactly 30 seconds more, not more than that. Give your best here. Try to apply the verification process here. Please do that. That's why this entire session was for. Keep applying the verification process. Come on, you can do it, guys. Just enjoy doing your numerals. Come on. You have exactly 15 seconds left. Great, guys. I could see many answers in the chat, man. This is superbly rocking. Very good, guys. You have 10 seconds left. And now you have 5 more seconds left. And your time ends in 3, 2, and 1. Time's up. Let's try to solve this question with utmost confidence. A convex mirror. As you know, this is the most important part for us. A convex mirror. And you know what? For this, I don't even have to draw the ray diagram. Because I already know. Because as you remember, for sign convention for convex mirror, each and everything was always. There was no nothing else, anything. So I know for a convex mirror, magnification will be positive. It will be less than 1 always. V will also be positive completely. It must also be less than the focal length. I know that also. Everything I know. I don't even have to talk about it. H dash is also going to be positive. It's also going to be less than 1. It's less than H. Completely super. No need to do anything. Just do that. So now it says used as a rear view mirror for a bus has a focal length of 200 centimeter. Okay? Focal length F is equal to positive 200 centimeter. Awesome. So focal length is 200 centimeter. Chalo, maan liya. Okay, let's note it down. Anyways, let's do it because it's simple. Anyways, 200 centimeter. Okay. अब आगे बढ़ते हैं. Before noting this down, since I have the magnification criteria here, positive and less than 1, let me see. Negative out of the picture. Negative out of the picture. Oh, 2 positive values which are less than 1. Okay. Now complication. Now let's solve it. So F is equal to 200 centimeter. Okay. Acha, I think we can. Acha, I'll tell you that way. I'll tell you, don't worry. So I have V is V, I don't know. U is equal to given as 100 centimeter minus, I think. Yeah. Yes. Okay, 100 centimeter. So minus 100 centimeter. Let's find it out. What is the answer? So 1 by V will be equal to 1 by F minus 1 by U. So your answer would for this question would be 1 by V will be equal to 1 by 200 minus plus 1 by 100. As you can see, we are already getting a positive value. 1 by V will be equal to 300 divided by 200 into 100. That's going to be 0 cancel, 0 cancel. Oh my god, 300, right? I've written one extra 0, my mistake. Okay, so now I have V is equal to 200 by 3 centimeter. You can divide it or keep it as fraction. I would request you to divide it. So once you divide it, you will get somewhere about 66.6667, correct? Something of that sort. I believe you will get. I will request you guys to have it. And as you can see, V is equal to positive value you have got it, and it's also less than your focal length as we wanted. So all set. It is a correct answer. I would request you to take the fraction for the magnification. You know why? I'll tell you. Look at this. M is equal to minus V by U. You have got negative 200 by 3. Divided by U is negative, nothing but again negative 100. Look at this, guys, very carefully. When you take it as a fraction, it's very easy to divide it. The whole point. So you get magnification is equal to 2 by 3. Hence 2 by 3 is nothing but 0.6666. A positive answer. Hence option B is the correct answer. And you could have done this. We would have actually chosen option B before even doing this part also, because I would like to state one thing very clearly here as a verification process, that is whenever the object, you know that image distance is going to be less than focal length. Correct. Image distance is going to be less than focal length always. So in this particular convex mirror scenario, you will always get that the value here is greater than 0.5. Almost always you will get it is greater than 0.5. So this could have been a really good guess completely if you would have given option B as the answer. That would have been a really good guess. Let's check out what is the answer. And definitely yes, it's option B. So bang on guys, you got it correct. Very good. So guys, with that, we'll end the session today. It was completely amazing. I hope all of you guys enjoyed it as well. Did you guys enjoy it or not? You didn't know? Very good. Please note down this as a homework and let me know what is the answer, and try not to solve this. Give an answer with only the verification process. That's it. Okay? Please note that down. This is the homework for all of you. Let me see who puts the comment the first, who gives the correct answer as soon as the session ends. Okay, let me just check it out. Okay, and before ending, once again, I would like to show all of you guys this particular link here, www.vdnt.in/numphysics10. Go for it. Let me know how many of you guys join. We are going to have a really good time. So with that guys, I'll end the session for today. Thank you. Thank you so much. You guys have been amazing. And till the next time guys, till the next master session, this is Abhishek signing off. Bye bye. Take care and peace. If you have any doubts and if you want me to take any particular topic for any video, you can put down that in the comments below. I'll be really happy to see the comments. I personally reply to all the comments. So great job guys. Bye bye and good night and take care. We'll see you guys in this session. Bye guys.